Good day, everyone. So, welcome back to my channel. No, and today we are going to continue on learning the principles of chemistry. This is lesson two, or this is actually in the book. This is lesson two, three, and four. No, and I'm going to break this down into parts one, part two, and part three, since this is a lengthy discussion. So again, we're going to learn the principles of chemistry today, and our topic will be the introduction to quantum mechanical structure, the electron configuration, and the periodic table. So, take note lang guys na hindi ko muna itatakal all of them because hinati-hati ko siya into three parts. Hopefully, three parts. Yeah. And let us start and begin our discussion. So, firstly, let us have a definition of terms. No, we have electron configuration. No, deals or talks about the associates the energy level with the number of electron in each level. So later on, kung magtatakil na tayo ng periodic table, you will understand the ano ba talaga ang purpose ng electron configuration. No, but again, the definition speaks to itself. No, nag-a-associate siya ng energy level with the number of electrons in each level. The orbital diagram shows the arrangement of the electron within each energy level. So, ang orbital diagram, no, nagre-represent lang siya yung arrangement ng electron with each level. So, parang ganito. If you have an atom right here, so imagine nucleus ito, no, you have this kind right here. So, it shows the arrangement, no, arrangement of the electron within each energy level. So, ano bang arrangement niya sa within each energy level? And also the periodic table, no, it is the electron configuration of elements that can be deduced from its position in the periodic table. So, periodic table just simply means that it you have the list of the element of all the element present in this planet, no, yung mga elements natin kita rin sa periodic table. Basically, it's just the list of elements and its information. So, let's talk about the atomic spectra. So, note that certain circumstances, atoms generate light transmitted through space. No? So, in the findings, no, atoms actually just not kanang hindi lang siya nag-exist because nandiyan lang siya, no. There is a special property of an atom when and under circumstances they generate light or transmit they generate light and transmit it through space. So a little advancement, no, atoms actually um, emit light as they go down the atomic orbital, and no, they release photons, no, and this is an example of which, well, fireworks, neon light, no, itong mga atoms na presence nito, they release photon as and as they release photon, no, yun yung unit for light of energy of light, photon. As they release it, they produces these bright colors, you know. And different colors are generated by the atomic spectra of different elements. So each element have a unique color associated to them. No? Very self-explanatory naman. So let's talk about wavelength and frequencies. Parang bumalik lang tayo sa high school, no? So when we talk about wavelength, it is the distance between two successive crests or throw in a wave, in a light wave. So we have here from BJU's website, no, credits to the owner. No, this is actually a crest kung pataas ka, and yung throw is yung sa baba. Ito, this is a crest again, and this is a throw. So a wavelength refers to the distance in between this crest and throw right here, no? Just refers to the distance lang actually. And this is actually measured in nanometers. No, please take note of the conversion factor that 1 nanometer is just equal to 10 raised to the power of negative meters, no. Very important ito siya when we compute for energy or the wavelength or the frequency, no. Take note of this conversion table later on. And also, when we talk about frequency, no, represent before we talk about frequency, no, wavelength, the unit of wavelength or the sign of wavelength is actually represented in this Greek letter. Now, this is what we call lambda. Lam, lambda. Ano to? Ito ba ang spelling? Lambda. Lambda. So, ganito ang represent ang tawag nyo, lambda ang tawag nito. And frequency, moving on, no, it is represented by V. No, what does frequency means? No, the number of successive crests or throw or the wave cycle that passes in a unit of time. So, if wavelength talks about this, the distance, the frequency talks about the successive, yung, wait, that's it, let's erase all the ink. Um, they refer to the successive number of crows. So, ilan ba ang throw or crest or throw na present in a specific time? Now, 1, 2, 3. Diba? 1, 2, 3. So, there is a 3 crest passing in 1 second. Ito yung ginadefine niya yung number of crests na present at a specific period of time. And also note that if 10 raised to the power of 8 cycle passes in 1 second, the frequency is 10 raised to the power of 8 per second or 10 hertz. No, frequency, the unit for frequency is actually expressed in hertz or in this form right here, second. No, or can be represented as negative second. S raised to the power of negative 1. Okay? Notice those conversion unit. Now let's talk about this. The speed at which a wave moves through a space is expressed in this formula, no? Lambda times the frequency is equals to c, where c represents the speed of light. Take note that the speed of light is constant. C is equal to 2 times 2.998 times 10 to the power of 8 meters per second. Okay, a little disclaimer right here. No, I'm using the book for this reference is Masterton and Hurley, the chemistry principles and reaction. I'm using that book as reference. So the speed of light may vary in different books. Some books would express this as 3 times 10 raised to the power of 8 meters per second. Either way, which one you choose, it derives still in the same answer. But I would recommend na you ask first your professor or look at the main references book that you are using right now, so that you when we solve problems, you do not commit some big errors, no. And yeah, please take note of that actually. So note that our wavelength is expressed in meters, no. To use actually this formula na lambda times v is equals to c, note that our wavelength must be expressed in meters and our frequency must be expressed in the reciprocal second hertz, which is actually in the form s to the power of negative 1. Okay? Bakit need natin parang ganito i-express ang ating mga units para maka-cancel out tayo ng ating mga units. Yun lang. It's very simple as that. Okay? Hope that's very clear. So let's have first a sample problem here. In a grocery store, no, a scanner uses a laser with a frequency of 4.62 times 10 raised to the power of 14 second raised to the power of negative 1 to scan the barcode on a power drink. Question: what is the wavelength of the laser? So, how do we solve this? So, what would I like to do is I first write the given. No? We start first with our given. So, in here, it says frequency. So, we are given our frequency, which is in 4.62 times 10 to the power of, ah, sorry, Just erase this right here. Times 10 raised to the power of 14. 6 raised to the power of negative 1. And we are asked to find the wavelength. Ano pang given natin? We are actually given our constant, which is the speed of light here. No, 2.998 times 10 raised to the power of 8 meters per second. So you look at the units, so naka-reciprocal na siya, no, appropriate ko na sila. So we are good to go. No more conversion factor. So let's have our formula right here. We have wavelength multiplied by the frequency is equals to the speed of light. So given that we are finding this one, we divide both sides by v. No, simple algebra right here, cancel out. Now our formula will be lang ito, wavelength is just equals to c over v. Okay, we have now our formula right here. So let's us use this to solve our problems. No, we can plug in now our values. No, frequency is just equals to this value, the value of our light, 2.998 times 10 raised to the power of 8 meters per second, and also 4.62 times 10 raised to the power of 14 um, sec- second raised to the power of negative 1. We cancel out the units. But wait, you might ask, wait lang, bakit ma-cancel out? Take note, no? Bakit ma-cancel out si second? Negative s raised to the power of negative 1 is actually can be expressed as 1 all over s. 'Di ba? And this right here, the form here actually sa bottom ko na to sa ato ang denominator, no, since negative we can express this as this form right here. We will have 4.62 times 10 raised to the power of 14 1 all over s over our speed of light, which is 2.99, sorry, 98 times 10 raised to the power of 8 meters per second. So applying the rules of division, no, ma-cancel out ang ato ang second right here, no. Yun siya, ma-cancel out siya, na-cancel out siya dito. So I'm just showing you the detailed part, no. And you plug this into your calculator. Approximately you have this value right here, 6.49 times 10 raised to the power of negative 7. Units natin is in meters. Okay? It is in meters. So, we are finding the wavelength. So, actually, you can still compute, no? Pwede mo itong, ang answer mo, ang final answer actually natin is 6.49 times 10 raised to the power of negative 7 meters. You can actually compute this into nanometers if you want. No, just take note of the conversion factor. You can, but this is already an acceptable reason. Okay? Acceptable reason. Acceptable answer actually. So, yun siya. So, if you just ask your professor if they want it to be calculated for nanometers. But if para sa akin lang, no, I'm not a teacher, but that's already fine with me. So, let's check. No, let's move on. So, ayun. Given natin. Ito ang mas clear, no? Actually, you can express this as S. Ayun. Na-cancel out ang units, na-cancel out, and this one right here. So, dito sa Masterstone and Harley, no, gi-convert lang niya into nanometers. But actually, this unit right here is actually okay na. So, ito na siya. Conversion lang factor, no? In 1 nanometer, we have 1 times 10 to the power of negative 9 meters. Yun. Just take note of that. Is equal to 6. Ma-cancel out ang unit, no? Then divide mo, kaya mo na siya i-divide, then 6, we have now 649 nanometer. I hope that is very clear to you. So let's move on to our sample problem 2. Now, next problem. The store pipe in a music from an FM station has a wavelength of this 286 centimeter. What is now the frequency of our station? So, ngayon, frequency naman ang ating ginapangita. So, again, we go back to the yung format natin, no, on how we solve our problems. No, we start first with our given 286 centimeter. No, we have this two, and take note the units. Okay, you cannot take note ha na when you use this form right here, wavelength multiplied by our frequency is equals to the speed of light. You cannot use this when your frequency, given that your frequency is expressed in centimeters, please express this in meters. So proper kuan lang para ma-cancel out nato ang ating unit. So I will not show to you how I convert it, but the conversion is 2.86 meters. Ito yung conversion niya. And the speed, again, the speed of light is already given na 2.998 times 10 is the power of 8 meters per second. Okay? And V is actually our unknown. So, okay na ang mga kuan natin units. So let's now use the formula V is equals to C, no lam frequency is times V times equals to C. Unknown si V, di ba? So let's divide both sides by our wavelength. Ma-cancel out. V is actually now C frequency. Then we plug in now our values. So the speed of light is 2.998 times 10 raised to the power of 8 meters per second. No, and our wavelength is 2.86 meters. May point po ito. No, and ma-cancel out ang sign natin. No, plug in the necessary value. Plug in this into your calculator. You have actually now the answer of 1.05 times 10 is to the power of 8, 1 all over s. Okay? Na-cancel out 1 all over s. But this can be written, no, this can be written as 1.05 times 10 raised to the power of 8 second raised to the power of negative 1. Inverse lang po, no? Ang inverse ng the inverse of this is actually this. Okay? I-move lang natin sa taas si S, kaya naging negative ang kanyang exponent. So I'm just showing to you the detailed part of the intricate part of our solution right here. Anyways, I hope that is very clear to you. No? Very straightforward naman ang mga calculations po natin. Okay, let's check. Let me erase this on the board. So, yan. Given, no? This is how we solve it. And we actually derive at the same value. Okay, let's start here. No, this just shows to us the wavelength of the visible light that we actually see. Take note here that the less than 400 nanometers is the ultraviolet ray region. Now, these are colorless na in nature, no, colorless na to sila. Di na natin to sila makita in our naked eye. But in for in 400 nanometers up to 700 nanometers, these are what we call the visible light. So at 400 to 500 nanometers, we can see the violet and blue. The colors absorbed is violet and blue. The color transmitted here is the red, orange, and yellow. At 500 to 580, the color absorbed was green and yellow. Then the transmitted color is purple. At 580 to 700 nanometers, the color absorbed was orange and red. And this emits a color transmission of blue and green. But okay, above 700 nanometers is what we call the infrared, or also a colorless region also. This is, both of them are colorless region, but in between them, these are the visible colors. Or actually, Roy G. Vib man to. Diba? So a little fun fact about the electromagnetic spectrum. The human eye can see covering only the region of 400 to 700 nanometers so. And our ozone layer, or at the top of the atmosphere, absorbs the harmful rays or harmful high energy of ultraviolet rays or the UV radiation sun. And carbon dioxide absorbs IR in radiation produced the Earth's surface. So imagine no yung ating um uh, ozone layer, no, gina-absorb niya yung harmful rays of, or the UV rays that can harm us. And if you imagine right now, our ozone layer is parang butas na talaga siya, and it's very dangerous actually to spend amount of time under the sun at a specific time kasi I think correct me if I'm wrong, at 10 a.m. right now it's very hot na, no, very hot. Even 7:30 is actually hot, and those actually contain UV radiation that could harm our skin, no, harm ourselves. So please take care when you are under the sun. So a little concerned by your chemistry tutor. So I'm showing to you here the graph, no, or parang illustration lang. If you really look at the the wavelength spectrum, no, our eye can only see the very thinnest part, no, gamay lang kaya to nakita actually, or gamay lang ang nakikita natin, no? Maliit lang yung kaya ng mata natin na makita, no, yung visible spectrum, napakaliit lang niya sa ating wide range of spectrum. No, at this level right here below, in this region right here, these are low in wavelength but high in frequency. Okay? So, since it is high in frequency, later on malalaman natin siya, no? It has more energy to it, no? Kaya dito, these are kanang high energy emitting uh, rays ito, like gamma rays and X-ray, no? That's why it is very dangerous when you are prolonged exposed to X-ray radiation. Kasi these are high energy radiation. As compared to this, no, this one has high wavelength measurement but low in frequency measurement. So there is a low energy emitted in this part right here. So dili masyado to sila harmful, no. Actually in this region, this the wavelength, or the wavelength here is actually used to transmit signals like radio waves, no, sa ating TV, sa ating cellphone, no. Yung mga signals na yan, o mga wavelength nila is mataas, but the energy that they produce is actually are not that high as compared to the lower region. So now let us continue our discussion about colors. So in chemistry actually guys, no, very important ang colors because colors can use to identify a substance. No, actually, color arises from a selective absorption and transmission of specific wavelengths of light. It is the selective absorption and transmission. Again, keyword here is the selective absorption and transmission of specific wavelengths of light. Example, in your laboratory, when you have encountered vapors of bromine, no, take note that this is a very corrosive material. Bromine, no, please take good caution of it, no. uh, Very share ko lang na in the your laboratories, when you are handling bromine, since this is a corrosive material, you could put it in a fume tube, fume hood, no, para hindi kayo amoy nyo directly ang vapors niya. You can use the fume hood. No, vapors of bromine and iodine are specifically red and violet respectively. So, an example of which this is bromine. No, when you take a look at its vapor, it is color red, and iodine. No, I got this from an experiment. This is actually the color of iodine. No, violet siya. And the solution for copper sulfate is in blue. No, actually, little fun fact. I think if I'm right, no, copper sulfate is somewhat a reagent on tawag nito pag detect if there is sugars. And potassium permanganate, you will use this very soon, no. You will use this oftentimes in laboratory. No, potassium permanganate is actually purple in color, and when you dissolve that in water, the color is purple. So before we end this video, let's talk about the particle, the nature of light, photons, and energy. Light actually is considered to be a stream of particles. Now, the stream of particles in light are called photons. So, and whose energy is expressed in E. So, we can actually express this equation, or the equation of light, in prior to the Planck's constant. We will use E is equals to hv. O And this hv right here, no, the Planck's constant multiplied by our frequency is just equal to the Planck's constant multiplied by light, the unit of light all over wavelength. Okay, this is just equal. Famously, no, in Einstein's equation, no, we express as E is equals to mc, diba, squared, no, where E is the energy, M is, I think, the mass, and C is the speed of light. Now, this actually is another form in respect to the Planck's constant. We express this in this form. The units for energy, take note, is joule. No, this is the SI unit. No, or expressed in 1 kilogram meter times meters per second all over second squared. Take note that in our constant right here, the constant is the speed of light, which is kanina lang na given ko na in one, kanina lang na mention ko na. H is actually is the unit for the Planck's constant, which is expressed in 6.626 times 10 raised to the power of negative 34 joules joules times second. Okay? Take note of this because we will solve a problem involving this equation in the next video. Take note that the Planck's constant and the speed of light, and the units for energy is joule. Start next. Lastly, is we have energy versus wavelength. So they are actually inversely related. When a wave is longer, the energy decreases. Katulad ng kanina, no, as the wave increases, no, mataas ang distance na nakakover niya, but there is low energy. Ang energy that was produced in this um, frequency, or the energy produced in this manner is actually decreasing. No? Example of it is infrared and microwave. Sabi nga nila, some people would say that when you microwave food, it's actually dangerous because of the radiation. But if we look at the principles of it, the microwave, no, mataas ang wavelength ni microwave. So therefore, there is decreasing of energy. Maliit lang ang energy na nai-emit ng radiation. While as compared to when wave is shorter, the energy actually increases. No, the as we decreases our wave, no, tulad nito, nag-decrease ang ating wave, no, wavelength natin, but we increase the frequency. Therefore, as our wave become shorter, no, the energy increases. Similarly, we can say this in our frequency, no, as the frequency decreases, no, the ener- the as frequency decreases, the energy decreases, and as the frequency increases, the energy increases. Take note lang, para mas madali nyong ma-understand, when we talk about wavelength, no, in terms of wavelength, the relation of wavelength and energy is inversely related, because as the wavelength increase, the energy decrease. But when wavelength is shorter, the energy increase, inversely related. But when we talk about frequency, no, frequency in relation to energy it is actually directly related sila, or correlational. When you say the frequency is decreasing, therefore the energy is also decreasing. But when the energy is increasing, or the frequency is increasing, therefore the energy is increasing also. They are directly correlational to one another. So I hope that is very clear to you guys. So dito muna ako magsa-stop ng ating lecture video today. So I hope you have understand the lesson that I discussed, and see you on the next video. Once again, my name is Jordan Hopi Julian, your chemistry tutor for this semester. So please like, share, and subscribe, and don't forget to comment down below. If you have any questions and query, just lay down in the comment section, and we will try to answer it as hard as we can. Thank you.